Good morning, Year 4. This is definitely not the way I thought we would be ending this maths unit, and I know that Mrs. Cross and my class taught the first lesson when we were interpreting time graphs on Monday, and I thought we'd be able to then get this one done in class. So I did not expect to be doing it from home, but I know you'll be amazing, and I know you have your maths books actually at home with you from last lesson anyway. So this is your math lesson for the Wednesday the 14th, and today we're going to be learning to construct a time graph. Now, hopefully you know what the word construct means because we looked at it last week when we were looking at bar charts. But in case you've forgotten, it just means to build or to create. So we're going to be doing that with time graphs today. Okay, let's get started then. Last lesson then, as I mentioned, we had a look at interpreting information from a time graph. So what can we interpret from this graph? We can have us see both sides, the X and the Y axis. We can see that time is written on the X axis, which is at the bottom, which is 8, 9, 10, and 11 o'clock. And then up the Y axis, we can see distance in miles. And if we read here, it says it's a time graph to show distance traveled by Raj. Okay. So let's have a look at the questions then, just to recap what we did on Monday's lesson. It says, how far had Raj travelled at 8 o'clock? How might we work this one out? So just in case you can't remember, I'm going to be using my line tools. That's going to be able to show you where I'm working from. I'm going to do it in a red so that you guys, can see the difference. And I'm going to be looking at the time first of all. How far had Raj travelled at 8 o'clock? So I'm going to go to the 8 along the bottom, and I'm going to go in a straight line until I hit my line data. And then from that line, I'm going to be able to go to the left on the Y-axis then and see that it lines up with 2. So I know that Raj had travelled 2 miles. Get rid of that one. 2 miles at 8 o'clock. Oh, and you're going to have to get used to my funny writing with my trackpad again. Next question then, how many miles had Jack travelled at 10:30? Why is this question trickier? Hopefully you'll be able to see by the data at the bottom, it's just because it's in the middle, but I still work it out in the exact same way. So this time, I'm not looking at 10 o'clock, I'm not looking at 11, but I'm looking in the middle. And I'm still going up in a straight line, even though it's black now, still up to exactly where the line is, and then across. And how many miles has he walked or travelled? He's walked 6 miles. Okay. How many miles did Jack walk between 8:30 and 11? That's my final interpretation question. So just as I did last time, I'm going to take another colour now. I need to make sure I start at 8:30 this time. So I'm going to go between 8 and 9. So 8:30 is here. And I'm not just saying that the answer is 3 this time. This time it's how far did he walk between this time and another time. So between 8:30 and 11. So I'm going to do one at 8:30, one at 11, and then I'm going to be comparing these times. So over here, I'm going to be comparing that he had walked 3 miles already by 8:30, and then he had walked 7 miles by 11 o'clock. So we're going to be doing 7 take away 3, or the difference from 3 up to 7. So he walked 4 miles between those 2 times. Now, hopefully you can see, just as we spoke about on Monday, it's really useful to always draw on our time graphs. If it's dotted lines, it just makes it really clear, and it's all about those straight lines. So recapping last lesson, how does that help us today, I hear you ask? In this lesson then, you know that we're going to be constructing time graphs. Constructing, we know from when I mentioned on the first page, means to build or to create. So you are going to be making your own time graphs today. Now, you did this brilliantly last week when you were doing bar charts, and we know that we're going to be drawing our X and our Y axis, and we know that we're going to need to do some labeling. But what information do we need, what information do we need to be able to construct a time graph? Could I do one based on the things that you can see on the screen at the moment? Hopefully you're saying no, because we haven't actually got on the data. So let's have a look at this then. Let's look at this data here. I've got day on one side and I've got height on the bottom here. So days in 0, 2, 4, 6, 8, and then height in centimeters, 0, 2, 3, 5, 7. So it says here on the right-hand side, before I look too much at the data, in order to construct a time graph, we need to have a table of information. So we've got that now. Then, once we have seen this data, we need to decide on a sensible scale for frequency on the frequency axis. So we know on a lot of them, the frequency axis is going to be on the y-axis. So having a look at these numbers here, 0, 2, 3, 5, and 7, look at the second row and decide on a scale. What would be a really useful frequency scale for those numbers? Are there a pattern in any way, or do they have anything in common? I'll let you have a little think about that, but hopefully you're shouting at your computer or you've got the answer in your head. Okay, so I've just moved the table over to the side and we can have a go then at starting writing our table. So this is just that I'm going to do with you and show you how to do it. You don't need to draw this one, but I've got my X and Y axis already drawn and we're going to write our frequency. So you're looking at 0, 2, 3, 5, and 7. You might have decided there's no real pattern in there. They're not all in the 2 times table. They're not all in the 3 times table. So maybe we might start today just by going up in ones. So I'm going to do 1, 2, 3, 4, 5, 6, 7. And while we're here, let's think about what those numbers mean. They mean the, there you go, it's the height in centimeters. So you could write this then sideways, H-E-I. And having to write with my trackpad and sideways is definitely interesting, but that's what these numbers mean. It means the height in centimeters. Okay, but now that we've done the frequency grid and we've decided we're just going to go up in ones for this one, we now need to have a look at the days. So this is where our bottom part comes in. So it's day 0, which we've got, which is going to be on this, on this line, then day 2, then day 4, day 6, and day 8. So I've just taken that information up here. And just so we know what these are the days. So I'm just going to write that subtitle in there, or my label for my axis. Okay, now that I've done that and I've labeled my X and my Y, we filled in the names on the sides, we're now going to plot our data. So I'm just going to use a different color just so you can see it. And in order to plot the data, we're just going to be reading it the exact same way we did when we were interpreting. So on day 0, the height is 0. So on day 0, the height is 0. I'm starting with plotting right in the corner there. Next one, on day 2, the height was 2. So I'm going to day 2 on the bottom, going up to 2, and I'm trying to get that cross exactly on the line so it makes it really easy. On day 4, the height was 3. So on day 4, I go up and again, my cross nice and neatly there. On day 6, it's 5 centimeters. Again, popping it right on that cross. And on day 8, it was 7 centimeters. Okay, so I've now plotted my data. However, the thing with time graphs, we know this data is continuous. This means it keeps going. So whatever we're looking at here, the days and something growing, which we haven't actually decided yet, and it didn't tell us in our table, we need this continuous data because it doesn't, or whatever's growing, doesn't just grow on day 2, stop until day 4, then start at day 5 or day 6. So I need to get my line tool, and I'm going to make sure it says straight line. And the last thing I need to do is to join up my points with those straight lines. It's really important to do this step because this will allow us to then go in between our separate days. So I knew, for example, that if I was going to be having a look on day 7, I'd be able to go up my day 7 line, and I've now got some data there. Okay. Last thing then for us to decide is to show what. So this might be a time graph to show a plant growing. So it might be a sunflower. So sunflower's growth over time. Oh, let me pop that there so you can see it. It would help if I could spell it. There we go. So this might be a graph to show a sunflower's growth over time. We have everything we need on that graph. We've labeled, we've plotted our data and drawn the line, and we've then finally created our title. Now I actually just labeled my X and my Y axis as I put my numbers in, but it's up to you if you want to do that in a different way. Let's just have a look at this same data again. Is there only one way to construct that graph? We could construct a second one, and I could model to you how to do a second one. And now I'm not going to for now, but just have a look at this data here, 0, 2, 3, 5, and 7. I didn't have to do it just using ones. So I could just very quickly model that if I'd have chosen the 2 times table, for example, so the 2, 4, 6, 8, 10, and I don't actually need to go higher than that because my last height is 7. And my days would be the same down here, 0, 2, 4, 6, 8. I can very quickly map the data just on a smaller scale. So I'm just going to change my color pen again, go back to red. So it's still 0, 0, 2, 2, but you can have a look now, the grid is already, or the data is already going to be squished up a little bit. 4, 3, and that just means I'm going to have to go into the middle of my lines here because I know my 3 would be about here. 6, 5, and 8, 7. So again, I would join those up, making sure it's my line graph data or it's my time graph. And this is just another way to do the, oh, not with a green line. This is just another way to do the exact same graph in a different way. And the only thing I've changed is my frequency scale on the side. Hopefully you'll see that it looks similar to the last one. Let's just see it again. But it's just been condensed down. Okay, let's have a look at a different one this time then. This time we have some different data over here, down here. Let's construct this bar chart together. So we've got different days, 0, 5, 10, 15, and 20. And this time we've still got height, but we've got 0, 40, 90, 110, 130. Okay, looking at this data, is it going to be a good idea to do my data in ones or even twos up the side? Hopefully you're looking at the data saying, no, that really wouldn't be sensible because of the high numbers I have. So I've got 130. Even if I was doing it in twos, it would take me a long time to get up to 130. What else do you notice before we talk about the data even more about the grid this time? Hopefully you'll notice that there are some thicker blue lines and they might be helping us when we're looking at our numbers and things. But what might be useful? Hopefully you're going to be screaming at me. Hopefully you'll be able to say it might be easier in tens. So I'm going to get my black pen and start with my frequency first of all. So 0, 10, 20, 30, 40. I'm going to pop my 50 on here. I'm not actually going to do all the question marks. And I'm going to pop my 100 up here. Does that mean my frequency is going up in 50s? Because I've just put 2 numbers in. No, hopefully you'll realize that we take the frequency from every single little line. So even though I've just put 2 numbers in this time, my data is still going up and my frequency is still going up in tens. Then on the bottom, I'm going to pop my days in. So I've got 0, or where am I going to put my days this time? 5, 10, 15, 20. I'm going to have to pop my 5, 10, 15, and I'm actually going to have to pop my 20, 16, 17, 18, 19 on this line here. So it's always useful just to make sure you check before you start that your lines are big enough. And you can see now that I've just, well, I can't move that blue one, but I've just made that big enough to use. Okay, just like I did last time, I'm going to make sure I know what those numbers mean. So over here, we've got height in centimeters again. It's really interesting to write sideways with the trackpad. So height in centimeters. And this one here again is days. Now again, we're not sure what's growing here or what's going to happen, but we can come up with the title last. So let's now plot my data. 0, 0, starting off quite easily, 0 on the X and 0 on the Y. 5, 40. So day 5, 40 centimeters. So I know if my 50 is this bigger blue line, it's going to be 10 centimeters lower. So on my next line, which is 40. Then I've got 10, 90. And I know that's going to be one lower as well. Then 15, 110. So it's going to be 10 over. And again, if you want to do all these numbers on the side so you know exactly where they are, that's absolutely fine. And finally, I've got 20, 130. 15, 16, 17, 18, 19, 20, just checking on the line, making sure it's nice and spaced out. 110, 120, 130 would be there. So we now have our data. And before I can say I've finished, I do need to make sure I'm joining these up because it's continuous data. Whatever it is keeping on growing, even on the other days that we haven't got the data for. It's still growing day 4, still growing day 13, still growing day 18. Okay. Final thing then, we have, let's just double check, we've done our frequency scale on the y-axis, we've filled in the columns on the x-axis and the y-axis, we've plotted our data and joined it up with straight lines, and we've labeled the x and the y-axis. The last thing we just have to do is create a title. So because this is made up data, we could call it whatever we wanted, but what roughly do you think is going to grow 100 centimeters in 20 days? What could it be? Might be the start of a tree, might be, can't think of something else, so it might be a time graph to show the growth of a tree. Okay, just going to move on again here then. Is there only one way to look at this data? Looking at the numbers I had, that's 0, 40, 90, so I'll go back. These numbers here, could I have done it in a different way? Now this time I'm not going to show you the alternate way, but I'm sure you can think about another way we could have looked at those data or looked at these numbers, the 0, 40, 90, 110, 130. Could we have gone up in 5s? Could we have gone up in 20s? What would have happened? But there is loads of different ways to do it. Okay, your activity here. Do not construct the graphs here. That's all I'm going to say to start with, because you'll be here a long time with our actual activity in a minute if I was asking you to draw 2 graphs. But can you just have a look at the data below here? There's 2 sets of data. And can you decide what frequency you could use to construct those graphs? I'm going to ask you to pause the video here, have a think about it, and then just unpause in a moment and I will talk through it with you. Off you go. Okay, well done having a go at that if you were able to. Let's just have a look at this data then and see what we could have done for our frequency, because this is often the bit that we need to think about, and it's the first step I've done in the other lessons. So I have this time months on both sets of data, but I'm going to start with this one on the left first. I've got month and temperature. So the months would be across on my x-axis and the temperature would be on my y-axis. So let's have a look at the data then. It ranges from, what's my smallest? My smallest is 5, and that's either January or December. And it goes all the way up to 20, which is to July or August. So I'm guessing this might be the temperature in England, potentially. Having a look at my data then, I've got between 5 and 20, and I have some odd and some even numbers. What did you think would be a good scale, maybe? Some good ideas. We could go up in 1s. There's nothing wrong with going up in 1s. If you want to be a bit more excited, going up in 2s might be a good idea. Potentially you could go up in 5s, as long as you had the bigger ones and you had the extra ones along the side, but lots of different choices there. Let's go on to the second one then. This time we have month and we have rainfall in millimeters. So looking at my numbers this time, I'm not sure 1s or 2s would be the best way to go, but let's again have a look. My smallest number is 38 for March and April, and my largest number I have is 65. So it's looking at what numbers would go up, not to have a really, really big graph or really big time graph, but what would be really good to use. I would suggest potentially up into 10s, as long as you had smaller divisions in between. You could potentially use 5s, so let me just write these down, 5s or 10s potentially. But I think anything smaller than that, and you would have a very, very long time graph, and you'd spend a long time writing the frequencies. Okay, let's have a look at our Emmett problem. Now, hopefully before I even read the question, you are screaming at me. Emmett thinks that he has constructed a time graph. Explain why he is incorrect. So this is a time graph to show distance traveled by Phoebe. I'm just going to pause the video here, or let you pause the video here, because you should be able to tell me what is wrong and what he has done. Okay, hopefully you are telling me that Emmett has made a big mistake and he has tried to do bars with his line graph data. Emmett has not joined up his data correctly. Hopefully you are telling me that, and let's just move that out of the way. He needs to join his data up. Oh, whoopsie. Let's enable you to actually be able to see that. A little bit smaller so it fits on the page there. Oh, I'm going to try. There we go. Emmett has not joined up his data correctly. He needs to join up his data up with a straight line as it is continuous data. And normally I know that we like you to show what he could do to improve it, or show the right answer. You can even show me what he should have done with those straight lines. Okay, your activity today then will look a little bit like this. Your do it task. You've got two pieces of data, two tables. Can you please construct a time graph to show, first of all, the growth of a bean plant, and the second data is to show the temperature change. Can I just make sure that you are really careful with the frequencies you pick? So the day and the time on both of them, which is the top ones on both, is going to be your x-axis. They are given for you. But your temperature and your height up the side, they are the ones that you have to choose the frequency. Now, the numbers aren't huge, but just think about the best ways to do it each time. Your go deep activity is then very similar to your Emmett problem. So it's a Coco problem. Tell me what she has done wrong. Tell me why. That's really useful, and maybe even correct it. And then if you get onto the go deeper today and you really want to challenge yourself, it does say as a class, because we were going to be in class, but maybe by yourself, choose a country of your choice and just research that temperature change. Remember on the last page, I said this is probably the temperature for England, but choose a different country. And can you construct a time graph to show the change in temperature during one day? So you don't have to do 24 along the x-axis and tell me over every single hour, but maybe choose a few along the bottom and plot it over the day, what happens to that temperature. Then if you can ask 3 questions that could be answered for your graph, those would be amazing. Good luck, guys. I hope you enjoyed this today. What I will try and do is pop some graph paper along the bottom if you don't have any squared paper at home, but you can just use your maths book or any squared paper you have. Just remember to come back at the end if you can for the learning pit, and let's see how well we did. Good luck. Okay, well done, Year 4. You have done amazingly, I am sure. And if you choose to send this work in to either me or Mrs. Plews today, we would love to see it. But just think about where you are on that learning pit today. Did you find that harder than you thought it was going to be? Was it easier? I reckon you've done amazingly at home, and it's hard doing it on the screen and not actually showing you or doing it with you, but I'm sure you've done amazingly, and I can't wait to see it. I look forward to you coming back tomorrow for your next maths lesson. It won't be on graphs, and what I'm going to have to do is merge up a couple into our final unit just for our last lesson. Look forward to seeing you then. Take care. Bye.